This is the desktop you will be getting, virtual desktop you will be getting. This is the terminal window where you will be typing the commands, terminal window for typing the commands. And then for opening a new file, so the command is gedit filename.tcl, gedit filename.tcl. So I have put file name wired.tcl. TCL means tool command language. TCL means tool command language. For opening a new file, it is maybe in review somebody asks you questions, you should be able to tell. They will check you whether you know the software, something like that. What is the command for opening a new file? Means you have to tell the command. Gedit file name, anything you can give. Filename.tcl. Enter. Already I have typed the code, so there is some code. Otherwise, it will come as a blank page. Already I have typed and checked the working. That's why some coding is there inside. But if you do it, it will be a new file. Okay, blank file. You have to type the coding. So roughly I will explain the coding. A new simulator we are starting. And this is the trace file. Out.tr is the trace file. You are opening a new trace file. And trace file name is out. Trace file name is out. In the communication happening, whatever packet sent from source to destination, all the information will be stored in the trace file. Trace file will contain all the communication details, whatever taken place between source and destination. Okay, any intermediate nodes are there, that information also will be recorded in the out.tr. TR means trace. Then you are opening a NAM file. NAM means network animator, animation window. NAM means network animator, animation window. You can see how the nodes are working. This is an animation window which will open. You can see how the nodes are working. File name is again out. I have given trace file name out. Okay, .tr. And an animator window also out. Name I have given out, out.nam. Okay, out.tr, out.nam. I am opening two new files, one trace file, one NAM file. Okay, animator file. I am taking 4 nodes. If you see 0, 1, 2, 3, I am taking 4 nodes. And here between node 0 and node 1, I am giving a duplex connection. Okay, simplex, duplex, you know. Simplex means one-way transmission. Duplex means both-way transmission. N0 can transmit to N1. N1 can transmit back to N0. That is duplex, full duplex, half duplex, something like that. Okay, simplex, duplex. So two-way communication, I am giving the setting. And this is the data rate, 10 megabits per second. Okay, 10 megabits and 5 milliseconds. Drop tail is the queue name. Okay, there is some channel. The channel is called queue where the packets will be transmitted. There are 2-3 different types of channels, pre-queue. Okay, like that. Drop tail is the queue I am using. This is a wired connection. File name itself I have taken. This is a wired connection because I am giving a link, duplex link. Similarly, I am connecting a wired connection between node 2 and node 0. Connecting wired connection between node 3 and node 0. Now I am putting the nodes N0 and N1. N1 should be in the right oriented of N0. Okay, N1 will come to the right side of N0. Location I am fixing. Now coming to N2. N2 will come to the left top of N0. Okay, left up. With respect to N0, N2 will be left upside. And N3 will be left downside. N3 will be left downside with respect to N0. I am going to simulate it for 50 seconds. And after 50 seconds, it will be halted. And NS run, start the simulation. Okay. After typing this, you have to save and then close it. If you close the file, only then this cursor will come for you to type in the terminal. This is the terminal window. This is the terminal window where you will be typing the commands. Once you close the TCL file, only then this cursor will come. Now for execution, command is ns filename.tcl. ns filename.tcl. This is execution command. Okay. Enter. It is executed. Okay. And now NAM. This is for seeing the animation window. NAM out.nam. This command is for seeing visualization of the animation window, network animator. Okay. NS wired file name.tcl, ns file name.tcl. For animation window nam, again this is file name.nam. Okay, in the coding I have given out as the file name, so file name.nam. Enter. Now, as I told you, node 1 is to the right side of node 0, node 2 is left upside, node 3 is left downside. Whatever you fix, that will come here. Okay, if you execute, no packets will be transmitted, because in the coding I explained only node location. I didn't discuss anything about packet transmission. Okay, so no packets are, I have clicked in the run button. Similar to our videos, whichever we play, this is the run button. You have to click the run button. So nothing is going on because packets are not allotted. So I will close this. I will add the packets. This is a new file what I have. This is a new file. Okay, wired 1. Okay, the previous coding as it is. If you see the previous coding as it is, after arrangement of the nodes left up, left down, I will be typing the packets, UDP packets, user datagram packets. Okay, I have connected node 3 and node 1. Packets will flow between node 3 and node 1. Okay, and this is CBR traffic. Okay, new application, agent window, packet size is 5 and 2 bytes, and rate of transmission, speed of the packets is 200 kilobytes per second will be transmitted. I am simulating 50 seconds. I will just execute the packets between 5 and 45. Okay, between 5 and 45 seconds there will be flow of packets. Before 5 seconds no flow of packets, after 45 no flow of packets, but the entire execution of the network will happen for 50 seconds. This is the packets I am adding. Now save this. File name is wired1 now. You can see the out.tr, out.nam I am maintaining same. Out.tr, out.nam. Okay, so I have added the packets. Now I have to execute the file. File name is wired1.tcl. I am executing the file. I have to check the nam. I am checking the nam. Okay, same nodes are deployed. If you execute it, here is the time. Okay, this timer will move very slowly. This bottom timer will move very slowly. If you want to make it fast forward, okay, just slightly drag it. So timer is slowly moving, and here only after 5 seconds, now packets are flowing. 5 seconds, packets are flowing. Up to 45 here, up to 45 seconds, packets will keep on flowing. I have given packet flow between node 3 and node 1. Okay, node 0 is the intermediate node, so via node 0 it is flowing. Because no direct connection between 3 and 1. So this is the possible way. So packets are flowing, 33 seconds completed, up to 45 seconds. Okay, this is just fast forwarding. It will happen little bit fast. After 45, packets will stop flowing. After 45, packets will stop flowing. This is as per the coding what we have done. Okay, cursor is not coming here. This NAM console also you have to close. Okay, only then cursor will get closed. Now I have another file. gedit test.awk, or what I will do, out.tr. gedit out.tr. This is trace file. Okay, here you will not write any coding. Whatever packets flow happened till now, that will be visible in this file. CBR packets are transmitted. Okay, so plus means NQ, minus means DQ. Packets are there in the queue. Before getting transmitted in the channel. So plus means it is ready in the queue. Minus means it is out of the queue. Okay, R means packet is received. So this is happening at 5 seconds time. From node 3 to node 0. Okay, this is the time. Plus minus R is the status what is happening, and this is the time at which it is happening, and this is the source node, this is the destination node, what type of packet and what is the packet size, something like that. Okay, So format is there for trace file in wired communication. You can get it all in Google what every column means. This is the time is 5.00541. Packet is received. In the third line you can see packet is received at a time 5.00541 and packet is from 3 to 0 CBR packet and 5 and 2 is the size of the packet. Okay, something like this. Now I have to count how many packets are received, how many R's are there. If you see how many line, my cursor is in line 1 here. My cursor is in line 1. There will be many lines like this. I cannot manually count it. If I put the cursor in the last line, so totally 11,724 lines are there in this trace file. 11,724 lines are there in this trace file. I cannot sit and count all this R. Okay. R means received packets. R means received packets. Okay. Only received packets I want for further calculation. So for that what I will do, I will open another AWK file. Test.awk file. Now I have to interlink the trace file and AWK file. GAWK minus F test.awk space out.tr space out.tr. This is the command. GAWK space minus F space file name dot awk where you have written that C++ coding file name dot awk and what is the trace file you are linking with the AWK to count how many R's are there, how many plus are there. Okay, this is the command. If you execute packet sent are 1954, received also 1954, no packet drops happened. So packet delivery ratio is received divided by sent into 100. Received divided by sent into 100, 100% packet delivery ratio is happening. Okay, this is how we will be getting the output. But what we have seen till now is wired communication. Wired communication. Without wire, our actual project is wireless communication. Our actual project is wireless communication. So now I will stop this wired communication here. I will stop the wired communication here.